My name is Izzie Johnson. This is my colleague Damani Richards, and we're here today from Wordnerds, a text analytics company based over the river in Gateshead. Today you get two Wordnerds for the price of one. And we're really excited to be here today to talk about the realities of building a specialist text analytics engine in the era of LLM and GenAI and all the existentialism that comes with that. And we're going to cover this from both a product as well as a technical perspective. In terms of what we actually do in context, we work with customers like Sainsbury's and Transport for Wales to ingest all their unstructured customer feedback, from their surveys to their social media, to their complaints, call transcripts, all that kind of stuff, and surface what we call actionable insights. It really is the name of the game. We often manage millions of items of feedback for a given customer, but we really go deeper than the sort of like headline statistic of, 1,000 people complained about hotel check-in, down to understanding segments of the data. So who are these people? Where have they come from? Even deeper, what metadata can we apply? What was their booking type? What was their room type? Deeper again, how can we enrich this data with KPIs so we understand actually the influence of these themes upon someone's satisfaction drivers? Deeper again, how can we overlay multiple themes and really explore the interesting intersection of two topics like hotel check-in with tendency to return to a hotel? So all of this is really so we can empower our customers to take meaningful action in their organizations to provide a better customer experience. Didn't know if this was appropriate for today, honestly. This is our CEO, Pete, at an event last year in London. It just felt like I couldn't not use it, though, with today's vibe, especially because to break the ice some more, again, like working for a specialist text analytics company is really hard in this day and age. We have very existential chats about like, God, are we going to be made redundant by the tech landscape? That isn't an elephant in the room. But the past 12 months have been challenging for many of us in terms of the Gen AI era. And I think for us in particular, the competitive landscape has changed so much. We're now day to day, we're not just compared to our competitors, but also to frontier LLMs like ChatGPT and Claude, where people ask, oh, why should I use you? Why can't I use them? So we're here really to give a really honest reflection on this journey, how we think we've come out on top, quick spoiler, and how actually we're working to integrate with GenAI kind of adjacent to it instead of being replaced by it in the long term.
Nice. So I'm going to take you through kind of one of the main products that we have. So we apply categorizations to data. We do keyword categorizations. What was more interesting and was, quite forward thinking at the time when it was developed was our old kind of context themes. Now I'm going to talk about the process for those because it's still really relevant to what we've built in the past year. But essentially our customers will send us their text data. That might be survey responses, that might be call transcripts. We take that data, we process it, we split it into sentences, and then we take each of those sentences and pass them through an embeddings model, an open source embeddings model. Previously, it wasn't an open source embeddings model. That's an important point to clarify. Previously, we used Google's API to generate the embeddings. That embedding, for people who aren't super technical or know a lot about NLP, is a numerical representation of that sentence. So if you imagine all of the embeddings together make what we call a vector space or an embedding space. And so things that are essentially kind of physically nearby to each other might be related. So if you have a sentence about a driver being rude and then somebody saying that they had poor service at a hotel, those might be close together because they're actually linked by the idea of customer service. It's a bit of a simplification, but that's a general idea. Once we generated those embeddings, what used to happen was a user would go and they would be kind of intelligently served examples and they would manually tag around 100. We would use those 100 to train a really small neural network. And its only task was to classify things as being in or out of that theme. And so what that neural network was using was all of the knowledge contained in that embedding space and those embeddings, and using that knowledge of the English language to help us categorize into the themes that we want.
Cool. And that process Damani's just laid out gave us three main advantages that we consider our kind of commercial product mode. The first is that it's deterministic in the sense that because we have the same embeddings model at ingest and we also use the same classifiers once a user has set up a theme, when they send more data to us through the platform, we process that data in exactly the same way as we did historical data. So that's really important for, say, housing associations that we work with who produce annual reports on topical themes like damp and mold or health and safety, whereby if they are doing trend analysis between 2 consecutive years, they need to trust that the thematic modeling for both years is consistent. Otherwise, the changes in volume and sentiment between those 2 years of data might not be insightful. It's just simply because the model's been segmented So that determinism is really, really crucial for us. And a really foundational part of, again, a kind of commercial moat. The transparency is also a very big part of it. This is a screenshot of a Trustpilot review that we processed at one point. You can see that every sentence that we have from verbatim, we can correlate it directly to the theme that's been tagged to it. So there is an audit trail. There is no kind of like black box sense you might get with a commercial LLM. And again, this is really important for us because some customers that we work with are liable for the reports that they send, especially to regulators. So it's really important they can actually have defensible data behind them. The third one is what I call nuance in themes. So you'll see in the screenshot here, the bottom sentence where this person has said they had to find it all out themselves on their package holiday. We've tagged this to a theme called cognitive effort. And this is a really important kind of theme for us that has like social or emotional layers to it. The person's not said directly, like, I had to do or think more than I wanted to on holiday. But we've found it and we've classified it in this way. And these themes are incredibly impactful to our customers because these social emotional themes link a lot to customer retention, customer churn, brand advocacy, reputation. So the level of insight we can generate from them is very elevated. And it's always been really important that we can maintain this like defensible nuance and themes going forwards for our customers. So for a while, we were pretty happy, I think, going along with our architecture. You know, we had a good kind of market share. We were growing. We are a scale-up company. As we all know, don't want to get too into it, but kind of end of last year, in the start of this year, the SaaS apocalypse arrived where overnight, just short of $300 billion worth of market cap disappeared as the market sort of evaluated different software sectors that they thought would be replaced by AI. That was death by one cut. Suddenly, I'm getting asked by all my customers, why can't I just use Copilot to do this? It's embedded in our tech stack. Why do I need you? Lying awake at night. Again, third dagger here is insights teams embedded in customers are starting to shrink due to budgetary pressures and expectations of AI upskilling. Insight analysts embedded in customers the teams are getting smaller, but they have more to do. Again, the AI era is really sort of like shifting expectations of our customers and how they're going to be using software as ours in the future. But it wasn't kind of the only issue we had at that point. Beyond thinking, oh my God, are we going to be irrelevant?
So yeah, as we were kind of confronting the threat that LLMs were posing to us and what we did as a business and the idea that they could match or even do better than what our current kind of abilities at categorizing text were, we also are kind of forced into action by a looming deadline. Because all of our small neural networks were based on these embeddings and we used Google's embeddings model, they were planning to deprecate it. Turns out they never actually did deprecate. I think too many people moaned, but it's good because it forced us into action. And obviously, if our embeddings model changed, then all of our classification models, and for one customer, they might have 150 of those models, all of those need to be updated. And so we needed to minimize the impact of that. At first, the goal was to just make it as not noticeable as possible. But in combination with, us using LLMs all the time, seeing how good they were, the same as our customers are asking was, why don't we just use an LLM to do all of the categorization? So to find the answer, we had to look at kind of three key factors for us. And that was just the accuracy, the cost of running the thing, and the speed of doing it. Specifically, the things that we were comparing was using a pure LLM approach. So you feed it the sentences, it tells you if it's in a category or not, compared to a hybrid approach where we build generative AI into our current kind of workflow. So to begin with, we explored getting as much as we can out of LLMs. We spent weeks experimenting with how we inputted data, the batch sizes, the output format, forcing output schemas to reduce kind of hallucinations or the hallucinations that our customers would see, playing around with definition structure. The way you asked it would change the accuracy. Which model did we need to use? How complicated of a model did we need to use? Could we use an open source one instead? And ultimately, what we found was that the accuracy was there. It was definitely better than what we were doing already. But the main limiting factor was cost. We worked out that to do a pure LLM approach for using Gemini by an API for our largest customer would have cost maybe around $30,000 a month. So just wasn't a viable option for us. Self-hosting similarly didn't make sense financially. We get loads of requests in bursts. We don't kind of have a consistent workload. So we ruled that out, and to build a kind of feasible approach, we dug into our current process and tried to understand where the limitations are. Now, for any of you who have built models, have done any modeling, you understand that it's usually always the same thing. And it was in our case. The quality of the data wasn't great. Our customers were making contradictions. They were making mistakes. They were probably getting a bit bored as they were tagging the data. And in about 10 minutes, people could only do about 100 examples, and people don't want to spend longer than that. So while a single person can tag maybe 100 examples, an LLM could tag 10,000 in seconds. And so that really was where we thought it might have an edge. Obviously, Gemini is a large language frontier model. It has a really good understanding of the English language and of context. So theoretically, if we use the LLM instead of a human to do the tagging, it would have a much better outcome for our kind of niche themes where they're kind of rare, not represented in the data that much, and might not be surfaced in just those 100 examples. So all of it suggested that instead of replacing our whole architecture, we could just swap out one part of it and bring Gemini into it. Whereas previously a user would spend maybe 10 minutes tagging examples, Izzie's going to show you a demonstration of what a user now does. So you would go onto the platform and all you do is you put in a theme name, and then you provide...
Of course, live demos don't work.
Hopefully the platform hasn't gone down while I'm presenting, but great. Then you provide a very simple description of what the theme is, what belongs, what doesn't. You actually don't need to put a huge amount of detail in here because once the definition is given, so Izzie's doing one on check-in time, once he presses this button, what happens is we send that definition to Gemini. It does two things. It reformats it, writes it in a better structure, thinks about kind of important inclusions and exclusions to bring in. And then it's going to go and do what a human used to do. So at this stage, it's going and tagging a sample of maybe about 1,000 sentences. And it's doing that to show you what we think the categorization will behave like once the model is enabled. So it's reading the definition, labeling examples, and then you can have a look here. If you scroll down a bit, Izzie, if you see it's rewritten the definition into a format that we found helps us with our results, covers the sentiment, it has some distinctions, and it has a little indication of what kind of things would be in or out of the category. So you can check if it makes sense.
Yeah. It's worth me saying here, this is publicly available data, not our customer data, because we have some customers in the room. Just on top of what Damani said there as well, in terms of like the volume of tagging, we can see here we've got just short of 1,900 examples that's tagged in those 45 seconds or so. So definitely an increase in speed there. Data match rate is shown up here at less than 0.5%. So again, not like a widespread theme in the data set that we have, but these indicators are going to be helpful to a customer to understand actually, is it a good theme and what kind of insights they're going to get.
So once you're happy with the results, which I think we are at this point, you go ahead and press next. Now, what happens now in the background behind the scenes is Gemini goes ahead and labels the full sample that we use. So we use about 10,000 sentences. That's about 1% of a lot of our customers' data set. So it goes through and it tags 10,000 examples. Those examples then become the training data for these small neural network classifiers. So the embeddings that were generated are fed into the model, and the thing that's trying to predict is the labels that Gemini has assigned to each of those sentences. And so for niche themes where the verbatim is really kind of sparse, there isn't a lot of those actual examples, we actually boost that as well at that point because we generate synthetic data based on the definition that the user wrote. We've actually found that even if there are no examples in their data set, we can still train a pretty good classifier just on the synthetic data. So once that's all happened, the model is trained, it's converted into Onyx format. And the reason we convert it into that format is because then it can be uploaded to BigQuery, which is a cloud database platform that Google provides. And it's also where we keep all of our embeddings. Now, why this is useful for us is because we can run inference inside of BigQuery for these small neural networks. And it actually means that we can apply our categorizations to the full data set of 1 million sentences in minutes, whereas previously it would have taken hours to even days for some of our customers.
On that, I'll just append as well, going back to product mode, you can see here, we're still deterministic, we're still transparent, we still offer actually increased nuance, while also riding on the coattails of the speed that Gemini and BigQuery offer. So it's been a real win for us to kind of follow this hybrid approach. In terms of proof is in the pudding, as Damani said, we estimated that for our largest customer with many million items of feedback, we'd be looking at about $30,000 a month of cost for running a pure LLM approach for that customer. Actually, with this hybrid approach, we're looking at more like $500 a month, which is obviously a great cost saving for us. Environmentally as well, there's a lot of interesting data we can pull around energy consumption here. Again, because we use Gemini only at that intermediary step, limited to only 1% of a customer's data set before we kind of propagate that model through our neural networks. Energy consumption is actually reduced by upwards of 97%. It's more like 99%, I think, if it's more than 1 million items in that data set. Again, really significant benefits for us here.
Yeah, so As Izzie mentioned, there's cost savings and there's environmental saving that is mostly driven by the fact that we're using this tiny neural network, which has maybe 150,000 parameters compared to a conservative estimate of maybe 4 billion active parameters when you're running Gemini Flash. So a huge difference in the amount of mathematical operations that are happening to process the same sentence. But our main kind of goal was to improve accuracy. And so from our previous F1 scores, which was kind of expected, we noticed around a 20% improvement in the F1 scores that we were observing in our test data sets. But what was actually probably more surprising was how close these really tiny neural networks got in accuracy to Gemini. We actually only noticed about 3% difference in F1 scores. Now, this varied depending on the theme. If you had a really complex theme, sometimes our small neural network struggled to perform on that. But actually, sometimes you did see improvements because it actually provided like a layer of abstraction, whereas Gemini might have overthought the problem and overfit it. The speed increase comes almost entirely from BigQuery. Moving from using Google's text embedding model, it was cheap and quick enough that we could do it on the fly. When we moved to an open source one, we needed to start generating embeddings as we got customer data. So that all was being pushed into BigQuery. And then a nice side effect of that was that we looked and we noticed that we could run inference there, and we noticed that we could run it a lot quicker. So what used to take days, weeks for our largest customer, we can now apply in seconds, minutes to their full data set of tens of millions of sentences.
This is our last slide. We haven't really prepped for this because I get asked all the time, what's the roadmap for next year? I don't know. It's a really hard market to be in. I think there's a lot of interesting stuff happening with sort of prediction, layering analytics with sort of predictive capability, statistical capability to like predict churn, things like that. There's a lot of cool stuff happening in the kind of digital twin area related to customer insights. But I think that some themes from today are very prominent for us. MCP servers, the concept of like agentic reporting with a data layer are all sort of in our minds. But again, we're still navigating this new era and the hype that comes with it.
Yeah. Thank you, guys. If you have any questions, I'm going to have to shoot. I was especially nervous today because I'm going to have my 12-week scan at the hospital after this. So I'm going to shoot immediately. So if you have any questions, I think my LinkedIn details are on the website. My name's Damani Richards. I think I'm the only Damani Richards in the country. So if you search me anywhere, you'll find me. So.